Hello, welcome to our YouTube channel BE Square. I'm your instructor for the course Electrical Energy Systems Renewable. The prerequisites needed for the course is electric circuit and electric machinery fundamentals. Moving on to the next point, there is some course outline we have defined for this course is wind power systems, types of wind turbines, power in the wind, impact of tower height, maximum rotor efficiency, wind turbine generators, and with many others. Each course outline will be explained in the upcoming video lecture series. The first topic is types of wind turbine. There are basically two types of wind turbine: horizontal axis wind turbine and vertical axis wind turbine. Let's study each one by one. Here is the pictorial representation of wind turbine horizontal axis and vertical axis wind turbine. Horizontal axis wind turbine has two other types, up wind turbine and the down wind turbine. But vertical axis wind turbine don't have any other further type. Okay, the upwind horizontal axis wind turbine faces the wind from the front side of the blades, and in downward axis wind turbine, the blades facing the wind from the back side. But in the vertical axis wind turbine, the blades are on the both direction and it is strengthened by the gear wires, and the blades are facing wind from each direction. Okay, moving on to the next point, there are some advantages of the vertical axis wind turbine. There is no yaw control system needed because the wind is facing from the both direction. It can rotate if the wind is from the back side, or if the wind from the front side. It can rotate in the both directions. So we don't need any yaw control system. And the nacelle, the housing which contains, let me show you, that contains generator and the gearbox. It is placed on the ground, so it don't need a strong power tower. And blades don't have to handle the constant flexing. This is basically the advantages. There are some disadvantages of this machine. There is the turbulent air because this machine is placed on the ground. Nacelle is placed on the ground. That's why the air don't have much higher speed, low speed, and the low power output. That's why the vertical axis machines are not preferred, and the most of the machines are horizontal axis, in which the most of the machines are upwind, because the downwind turbines have some disadvantages. One of the main disadvantages of the downwind is wind shadowing. Let me show you from the diagram which was described below. This is downwind. Actually, there is the tower between the wind and the blades that create a shadow on the tower, and the wind don't face this blades don't face this wind. This is what called as wind shadowing. That's why there is some disadvantage of the wind turbine in terms of low reduced power output. Moving on to the next point, there is the power in the wind. How to calculate the power in the wind? By using the formula half rho AVQ. PW is basically the power in the wind, that's calculated in watts, and rho is the air density that is calculated at standard 15 degrees Celsius temperature, and rho and 1 atmospheric pressure, and it comes to the value 1.2 to 5 kilogram per meter cube. A is the cross-sectional area and V is the wind speed, and this power is related to the cubic of the wind speed. Okay, what's the next point? There is area calculation. For horizontal axis wind turbine, we can calculate the area by using the formula pi by 4 d square. D is the diameter. For vertical axis wind turbine, area can be calculated by 2 by 3 d into h. D is the diameter and h is the height. Thank you so much for your interest, and the next lecture series will be continued in the next videos. Please don't forget to like, comment, and share, and subscribe to my channel.